Okay, Wildcats. Today we're looking at journal page 63, exponential base of e. Exponential base of e transformations. F of x equals negative times a e to the negative x minus h plus k. E is the exponential constant. When the negative in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the x inside the parentheses, it reflects over the y-axis. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. I would update your notes. Okay, now your notes are updated. Let's take a look at example number 1. Identify the key attributes of f of x equals e to the x, including the domain and range in set notation, the end behavior in all intercepts. Okay, so step 1, we're going to graph e to the x. So we're going to use our calculator. So I'm going to go to on, new document, add graph. We're going to do E. The E button is right here, e to the x, and x is right here. So press enter. Now we can see we have a horizontal asymptote at y equals 0. So let's go ahead and graph that first. Okay. All right. Now let's go ahead and get points to graph. Okay. So I'm going to press Control T, and let's start. Let's see if we can find any values. So you can see here that it's approaching 0. 0, 1 is a good point. And let's go ahead and graph that 0, 1. Let's see if we can find any other good points. So those would get way too big. Okay, so 2, you can get to about 7.3. So we could probably use that to 7.3. Okay, and then 320 is way too big. So we can use 0, 1, and 2, 7.3. Okay, so we know our graph goes along here, goes through, and then up like so. Okay, all right, go ahead and finish up the graph. All right, now the graph is updated, and I think that point be a little bigger. There we go. All right, now step 2, as x approaches negative infinity, f of x approaches 0, and as x approaches infinity, f of x approaches infinity. Step 3, the function does not have any x-intercepts, but it does have a y-intercept of 1 because f of 0 equals e to the 0 equals 1. So the y-intercept of f of x equals e to the x is 0, 1, which is this point right here. Okay? All right, go ahead and finish up example 1. All right, example 2. Graph the function g of x equals 1/4 e to the x plus 3 plus 2. State the horizontal asymptote, domain, and range. Okay, so we're going to graph that. So let's go to our calculator again. We're going to go to on, new document, no, add graph. Okay, so we're going to do control divide 1 divided by 4 e to the x plus 3, click to the right, plus 2. Okay, I'm going to move this out of the way, and I'm going to go to menu, view, grid, line grid. This is going to help find our asymptote. So you can see here that positive 1, positive 2, we have an asymptote at y equals 2. Okay, so let's go ahead and graph that now. So we have a horizontal asymptote at y equals 2. Okay, now let's go ahead and get some points to graph. Okay, so I'm going to press Control T, And I'm going to go to the negative, see if there's anything good. Nothing really good there. Maybe -3, 2.25, but let's see if we can find any whole numbers. Nope, that's probably the best we're going to be able to do is -3, 2.25. When you don't have whole numbers, you just pick the best you can. Looks like that might be okay. -1, 3.84, which will be okay. And then 0, 7, that's pretty close to 0, 7. So 0, 7. It's right here. Okay, so now we have our points. And so we know that it's going to fall along the asymptote and then go through and then up through those points. And there's our graph. Okay. All right. So go ahead and finish up your graph. Notice that I approximated the points, and that's okay. All right. Step 2. The horizontal asymptote is y equals 2. Step 3. The domain is x such that negative infinity is less than x, less than infinity. Step 4. The range is y greater than 2. And you can see the range is greater than 2 because it's greater than the asymptote y equals 2. Okay? All right, go ahead and finish up example 2. All right, example 3. Graph the function g of x equals -3 divided by 7 e to the x plus 2 minus 4. State the horizontal asymptote, domain, and range. Step 1, graph g of x equals -3 divided by 7 e to the x plus 2 minus 4. Okay, so let's go ahead and graph that. All right. So, calculator, there we go. On, new document, no, add graph. So then we're going to graph control divide -3 divided by 7. Click to the right, e to the x plus 2, click to the right, minus 4. Okay, press enter. I'm going to move this out of the way. And we're going to go to menu, view, grid, line grid. And that tells us, if that ever happens where I accidentally grab here, I'm going to press escape and I'm going to go to menu, window zoom, and I'm going to go to zoom standard, puts the graph back. Okay. So then here we have -1, -2, -3, -4. So we have a horizontal asymptote y equals -4. Okay. So let's go ahead and graph that. Y equals -4. Okay. So we have our asymptote. Right now, we're going to go back to our graph, press Control T to find some points. Okay. All right. That's not the best, but we can probably use -4. Well, that's really close to the 4 line. We don't want that. Let's try, see if we can find any whole numbers. Wow, no whole numbers. So, -1, 5.16 is probably going to be as good as we can get. So then, and then 0, -7.16. Maybe -2, -4 point, probably. Again, when you want to try to use whole numbers, but when you can't, you try to use the best decimals you can by approximating. Okay. So we have our points. We know this is going to fall along the asymptote. We're going to go through the points and go down. Okay. All right, go ahead and graph. Finish up the graph of example 3. All right. Step 2, the horizontal asymptote is y equals -4. The domain is x such that negative infinity is less than x, less than infinity. The range is y such that y is less than -4. And it's less than -4 because here's the asymptote, and you can see the graph is less than that. Okay. All right, go ahead and finish up example 3. All right. All right, example 4. Enter the function whose graph is shown. State the domain and range in set notation. Okay, so we have our graph, and we have these points. Okay. All right. So step 1, we're going to use a reference point -1, comma 5e plus 3 to find the values of a, h, and k. So first off, we know that we have the point -1, comma 5e plus 3, and we know that's equal to 1 plus h equals ae plus k. Okay, so we first set the 1 plus h equal to the -1, and we're going to solve for h. So we're going to subtract 1 from both sides, so that's -2 equals h. Okay. All right. So now we know a is in front of the e, so that's 5. And then k is 3. Okay. All right. So now we know our a value is 5, our h is -2, and our k value we're going to plug into this form. So g of x equals 5 e to the x minus h, which is -2, plus 3. Now we know when we subtract a negative, it becomes positive, so that's plus 2. Step 3, the domain of g of x is x such that -infinity is less than x less than infinity. Step 4, the range of g of x is y such that y is greater than 3. Okay. Example 5. Enter the function whose graph is shown, state the domain and range in set notation. Okay, so here's our graph. There's our reference points. Okay. So step 1, use a reference point -1. Or actually here, let me stop so you can update the graph if you need. All right. Step 1, use a reference point -1, comma 5e plus 3 to find the values for a, h, and k. Now we know that and that's actually a slight mistake. Let me correct it. This point is incorrect. Somehow there's a little typo there, but we can correct it very quickly. The point is 5, comma, -5 e plus 2. I apologize for that mistake, but it's corrected, and we can move on. Okay, so we know that this point is equal to 1 plus h, comma, ae plus k. Okay, so we set 1 plus h equal to 5 and solve. So we subtract 1 from both sides, so 5 minus 1 is 4 equals h. Okay, now we know that a value is here, so a equals -5, and k equals 2. Okay, all right. Step 2, write the function g of x equals ae to the x minus h plus k. Given the values a equals -5, h equals 4, and k equals 2. So g of x equals the a values, -5, e to the x minus h, which is 4, plus k, which is 2. Okay. Step 3, the domain of g of x is x such that -infinity is less than x less than infinity. Step 4, the range of g of x is y such that y is less than 2. All right, go and finish up your notes and examples and have a wonderful Wildcat day.